Okay, welcome students. I have drawn a pictures for you to show the Archimedes principles. So Archimedes principle for cylindrical body. Suppose this one cylindrical body that we are having water now any liquid, and I have considered one cylindrical shapes liquid here, this one, and see the difference if a cylindrical body where a cylinder of height h and area cross sections, this height of the cylindrical body is h, height is h, and area cross section, this is area of this one a. Okay, now see this, if the pressure, now pressure on the ups, this one also a, this one also a, the down one area also a, this one also a. So the pressure acting, let the pressure acting on the top floor, top surface is P1 into A. P1 into A. Okay. And let the pressure acting from the downwards to upwards is P2 into A. Okay. Pressure P2 and the force, the up thrust, the thrust downwards here P1 into A, and this one suppose F1 and this is F2. Okay. So, and downward the force acting is P2 into A. Now, what's the difference between the pressures? Force F2 minus F1 equals to what? P1, P2A minus P1A. Okay, or A into P2 minus P1. Okay, A into P2 into P1. Now, what will happen? Now the difference, therefore this is Fp, this is called buoyancy force. Okay, now buoyancy force, we know that pressure. So force is what? Nothing but the weight. Okay, so if I write this one weight, weight means F equals to the weight. This is the weight of the water. So this is mg. Mg means the g is the acceleration due to gravity, and m is what? That the volume, and into suppose rho. Rho is the what? Rho is the density of the liquid. So V into A is the equals to called the mass. Okay. F means F equals to mg. Mg, so V into rho. M means volume into density is called the mass. Okay, so if I put the volume here, now I am writing here Fb, buoyancy force. Fb equals to F2 minus F1. Now, A equals to, then I can write here V. V by, V means area into A into H. Okay, A into H, volume means what? Volume is A into H, cylindrical, pi r square H, isn't it? The volume of the cylinder is pi r square H. Okay, so instead of pi r square, I can write A, area cross, since it is pi r square equals to A, and AH, so for V I can write AH and into rho, and here is G. Okay, so for, if I can do the pressure P, pressure means F by A equals to called pressure P. Okay, so if I divide this one by A, then what will come? H rho G, or pressure PB, beyond pressure is H rho G. Means how we can define the pressure due to the liquid fluid, how that it is the product of the height of the cylindrical object and the density and the gravitational attractions of this area. Okay, in this way we can define the buoyant force, and due to this force the object will will be decided whether it will float or it will sink. And this is the Archimedes principle. So based on Archimedes principles of flotation, so principles of flotations. So what is called flotations? That a body which can float, that is the process by which a body floats is called flotations. Now the principles of flotation is its weight W acting downwards. What is the principle? The weight of the body will be acting downwards. If I immerse an object inside, if I immerse an object inside a liquid or in gas, then its weight of this body will acting downwards. Okay, and the next one, the upthrust FB, and upthrust FB will act upwards. So upthrust will act upwards and the weight of the body will act downwards. So when both will be equal, upthrust and the weight of the body, suppose FB equals to W, weight of the body and upthrust of the liquid will be same, or liquid or gas will be same, then the body will float. This is the principle of the flotations. But in between two, if any part, if F be lesser than weight, then the body will sink inside the water. Okay, so depends on Archimedes. The Archimedes were told that when we immerse a body inside a liquid or gas, so the object displaces the equal. If I suppose immerse this object, okay, inside the liquid. Now suppose we are having one pipe is there, outlet here. So when I immerse this one, so extra water will come from here and you will collect this water, okay, or any liquid. After immersing this one, when the liquid will come out from this pipe, and if you collect this one and if you take the weight of this one, then you will get displaced. That the weight of this water will be called the weight of displaced liquid. Displaced liquid. Okay, so if I take the weight of this liquid, and that one will be, we say the weight of the displaced liquid. Now this weight of this liquid is equal to the weight of the object. Weight of the object, then the object will float. Okay, but this is the rule of the, this is the Archimedes principle. The Archimedes principle told that the object is immersed partially or fully, so the object will displace its the object will displaced by liquid, and it exists and experience some upthrust which is equal to the weight of the displaced liquid. Okay, so this weight of the displaced, whatever the weight of this much force will act on the object, and this much force is equals to the weight of the force, weight of the object, then the object will float. But if the weight or the force of the displaced liquid or weight of the displaced liquid is lesser than the object weight, then the object will sink. Okay, so this is the Archimedes principle. Now based on this Archimedes principle, many things we can see that in many applications, that submarines, ships, the huge, one iron small block can sink, but whereas huge ship nicely float on the sea. So what is the difference? Because when the ship, see the ship's such a huge, volume. So when is just emerge on the sea or river, then what will happen? Since the maximum portions of the sea in the downwards is empty, so its density of this huge volume is very less. And when it's emerged in the liquid, so it will displace huge amount of water, and this displaced water's weight is much more than the weight of the ship. That's why the sea float. Same thing, the submarine. Submarines, you know, that they normally float inside. They float inside the liquid. So here in the submarines, they are having one ballistic tank. So ballistic tanks. So when this tanks, what is the functions of this tank? When the submarines, the driver, the pilot of the submarines, they need to go up. So what they do? They first, suppose here is submarines is floating on the surface of the water. So if it needs that, you have to go down of the water, or then what he has to increase its weight. So how it will increase? This ballistic tank, having here the ballistic tank. So here having a nozzle, he just let the water to get inside. If the water get inside and fill the tank, ballistic tank, then this tank, the water to make the full submarine's weight is more than the displaced liquid, displaced water, and that's why the submarines will go down here, and it will float in this inside the water. But when the pilot thinks that he let the submarines make it up above the surface of the water, then what they will do? They just pump out the water from the ballistic tank and make it empty. And if it become empty, then again its density become less and its weight also become less than the displaced liquid, displaced water, and the submarines will go up. In this way, many applications are there. That's balloons, airships, icebergs. Okay, now this one you can easily understand from the book. Online classes also I have explained. Now density and relative density. What is called density? Density, you know that density is equal to the mass by volume. Okay, mass by volume is called that density. Means if I take a block of suppose iron or whatever else, then if you make small unit, one centimeter cube, 1 centimeter cube, if you make so many pieces, and if you take the mass of 1 centimeter cube of the block, and whatever the mass, suppose this one for 4 gram, okay, and so 4 gram per unit, 1 centimeter cube. Because why 1 centimeter cube? 1 centimeter breadth, 1 centimeter length, height, and 1 centimeter length. So it is a 1 centimeter, it is, sorry, not here, this is 1 centimeter, 1 centimeter and 1 centimeter. So 1 centimeter means 1 centimeter cube. So this is called the density of the object. So what is the definition of density? Density is a mass per unit volume. So unit volume, how much mass is there? This is called the density. Now what is called the relative density? The relative density is density of substance by density of 4 degree centigrade temperature of water. Okay, density of water 4 degree centigrade, density of substance and density of 4 degree centigrade. Why 4 degree centigrade temperature? I already explained when I explained online classes. Because 4 degree centigrade temperature, why you have to take water? Because in 4 degree centigrade temperature, the density of the water is maximum. And after below the temperature, above the temperature, it may vary. But 4 degrees centigrade temperature, the density of the water is maximum. That's why we are taking the density of water is 4 degrees centigrade. So density of the substance by density of the, so why it is called relative density? Because it is a ratio of two types of densities. Density of substance and density of the of water. And that's why the relative density doesn't have any unit. Okay, and this one you also can write a unit mass of unit volume of substance in this way. You can write mass of unit volume of substance in place of this one, and mass of unit volume of water also. In this way, the relative density can, you can make the ratio of mass of the two substance, that what mass of the substance and mass of the water. And if I give what the relative density of copper is 13.6, then you have to, that means the ratio is 13.6. There is no ratio because it is a relative density. So what is the density of mercury? Mercury. Then what you have to do? You have to multiply this one by 1000 kg. Okay, per meter cube. If you, because this is a density of the water. So if you multiply the relative density into density of water at 4 degrees centigrade temperature, we will get the density of substance. Okay. So that's why, so if 13.6 is relative density, if you multiply this one, then we will get 13.600. This much kg per meter cube. This is the density of the mercury. So in this way you have to find out the relative density or density of the substance. Okay, this chapter is finished, and your consumption will be clear in this way. Thank you.